well, I guess it's showtime for me now. I promise I won't be doing any Joker dances here. So before we start, I have a quick question. Does anybody, if you look at these two characters, does anybody recognize them? Sorry? Oh, I wish it was Link. They're supposed to be Frodo and Sam. It's okay. I rewatched The Lord of the Rings a couple days ago, and then I realized Sam is not as blonde as I thought he was. So, my name is Alexander Chatzizacharias blah blah blah. It's a little bit of a tricky last name. I have a couple hobbies. I really love bouldering. I have a way too expensive Magic the Gathering collection. I went to the game store here yesterday, bought some packs, and I can gladly say I did again waste my money. And I play a lot of video games, like a lot of video games. And you'll probably see that coming back a little bit here. I've heard that my name is quite difficult to pronounce. So this being an AI talk and everything, and about RAG, I figured might as well ask ChatGPT if it can pronounce my name. So I did. And it's actually quite on spot, like Chatzizacharias. So that's pretty good. I was kind of surprised that it understood how to pronounce my name. But what worries me a little bit is I say, hello, my AI overlord. And it answers with, hello, my lawyer human. So chill down. We're not there quite yet. Skynet has not been invented. So a little bit worrying, maybe. Like Stefan you said yesterday, scary and exciting at the same time. All right. So this talk, how did this came to be? Roughly, I think 1.5 years ago, I read a paper on how they used AI agents to create NPC behavior. And NPC is a non-player character in video games. And they created like this whole town where NPCs were moving around, talking to each other, doing cool things. And that started making me think, okay, this is probably happening in the game industry sometime in the future. We're not quite there yet. And how hard can this be to make myself? So then I thought, okay, I'll just try doing that. Back then I wasn't really ready. I didn't really know a lot about AI. So past 1.5 years, I've dove into vector databases, large language models, RAG, all those kind of things. Try to understand how it works intrinsically. And now I tried to make exactly that. So that is a little bit what I'm going to be showing you today. I had a lot of fun making this, and hopefully you'll have fun hearing about this. Before we go into what I made, I need to make sure everybody is on a level playing field. So we start with RAG, one of the most important parts of the presentation. Retrieval augmented generation. Who here has not heard of RAG before? A couple of people. Okay, good. So it's good that I have the slides here. So what is RAG? There have been quite a lot of presentations on LangChain4j and things like that, and they probably mentioned RAG there as well. We won't be talking about this. No towels here and those kind of stuff. And if you Google RAG, this is a little bit what you'll see popping on the internet. So these architecture diagrams with arrows going left to right and people telling you this is a little bit what RAG is. In my opinion, that is way too complicated, and it can be explained much simpler. Because in my opinion, whenever you get a query from one of your users in your systems, and then you use that query to grab some data out of your dataset databases or whatever, and then inject that data in a prompt and go to a large language model, then you're already doing RAG. So it's a technique that allows you to make the large language model responses better by injecting your own data in the prompt. If you look at that, it's quite simple. In my opinion, it can be as simple as user asks something, you query an SQL database, you put it in a prompt, and then you are doing RAG. That name, though, is horrible, if you ask me. So it was coined in 2020 in this paper, Retrieval Augmented Generation for Knowledge-Intensive NLP Tasks, by Patrick Lewis and Ethan Paris. And what's kind of interesting is in an interview they said, that they would have definitely put more thought into the name, have they known it would become so widespread. And they always want something nicer sounding, but when it came to it, nobody had a better idea. And if this doesn't really summarize our industry, I don't really know what does. Just go with it, and it's going to be fine. So that is a little bit the RAG part. So what about the multimodal part? Because we're going to be doing that today. Multimodal means that you accept more data types except for text. So you inject audio data or video data or image data, 3D, IMU, so whatever. You inject into your prompts, or you grab from your vector databases or SQL database or whatever. And that is what makes the whole system multimodal. You support multiple modalities. So that's pretty straightforward as well, I would say. Today we'll be focusing on these three modalities. So we'll be doing things with text, audio, images, and that's it. So hopefully it's enough. Good to know, there's a non-zero chance that my laptop will be fried during the presentation, because I'm running everything locally. So everything you'll see today is running locally. Why do I run things locally? Well, I'm a backend developer myself, and of course we love local host, right? I'm also half Dutch, and I really don't like spending money. So when I did the calculations on how much requests I did and how much it would cost me to go to OpenAI, and so it would be like $3 per presentation, I was like, yeah, no way I'm doing that. So everything is local. I have a 16 gigabyte RAM machine, so it's not a lot. I do have an NVIDIA GPU. It's a gamer laptop. It has all kinds of nice RGB lights as well. And the NVIDIA GPU has 8 gigabytes of RAM in it. So it's not super beefy. And you'll notice that as we go on. And at some point, I'll be able to fry an egg on it. So all right. The most important part about this whole thing are the machine-trained models. So we have two kinds of models here. We have embedding models, and we have large language models. Everyone should know by now what the large language models do. Anybody that says no? Okay, good. And embedding models are actually models where we'll be sending our data to, and they will be vectorizing the data. So they will be creating an array of numbers for us that captures the semantic meaning of whatever we send to them. And that is really what allows the whole multimodal part. We're going to be creating embeddings with these models for text and images, and we'll be able to query each other through the use of these models. So that's pretty nice. All right, so that is a little bit of an intro. So let's get down to the nitty-gritty. So I spoiled a little bit at the beginning that there's a Frodo and Sam here. Has anybody not watched Lord of the Rings? One person. Can I give homework to people during these presentations? So anybody that doesn't like Lord of the Rings? A couple of people. I'm really sorry for the upcoming 40 minutes. Because what we're going to be doing is we're going to be injecting an imaginary village in the imaginary land of Mordor. So Mordor is like the land of the orcs, you know, bad, desolate, orcs bad. They like to, you know, wage war and whatever they do. And we're going to try and inject a village there that is peaceful, serene. The orcs just want to chill, you know, tend to their crops, fish, paint, things like that. And that is what we're going to be trying to do, and let's see how that works out. Let me show you my stack first. Maybe that is handy. We'll be using two different flows for this. So there's like this data ingestion step. I've done that all before because it takes a little bit of time to do during a presentation. And the data ingestion basically means, hey, I have all this data. I'm putting in a vector database or in a SQL database or wherever you want your data. I'm putting it there. and then it's ready to be queried during runtime. And of course, runtime means users will be asking questions, you'll be querying data left and right, creating your LLM, your prompts, sending them to LLMs, and getting response and showing that to the user. This is our stack. I'm going to be using VV8 for persistence as a vector database. I have a Spring Boot backend. I've been following a couple of sessions, and I also use LangChain. And during all those sessions, people were like, "Yeah, if you use LangChain, you probably want to go with Quarkus because it's much better support for LangChain, feels more native and stuff like that." I didn't know when I started making this. I went with Spring Boot. I couldn't really migrate to Quarkus at this point, but what I did is the next best thing. I grabbed the Spring banner. I just wrote Quarkus there. So now we'll start our server. So it's a Quarkus server. Totally not Spring. And I've written everything in Kotlin. Why Kotlin? In my opinion, it's the better language of the JVM. You can change my mind if you want. Try to change my mind. And we have a front end built in Unity. Anybody that has never heard of Unity? A couple people. Unity is a 3D game engine. So we have a little game where the villages and etc. will be using as our front end. And unfortunately, for some things, I actually needed Python, some Python code and a little Python server. I did see yesterday that we can also use Python using Graal and stuff like that. So maybe I'll be able to migrate this away in the future. Okay. So let's start the game. Not lying, it is made with Unity. So let me double check that the server is running good. So Frodo and Sam arrive at this village, different kind of orc village, Mr. Frodo. And then Sam is like, he wants to find some taters to make a stew dinner, and asks us to go and find the way to Mount Doom, because that is, of course, and then yeets away. So yeah, this is Frodo walking around. And we arrived in Little Minas Morgul, or LMM for short. And here we can see an orc already standing there chilling. You can see there are some requests going up and forth, so we'll just leave that go there. So if you have a village, the first thing that you want to do, of course, is actually have the orcs, the non-player characters, move around, talk to each other, have goals, things like that. So that is what we try to build first. So we have an orc. At some point, it's going to get like this realization, okay, I've been standing here forever. I need to go somewhere. And hopefully our large language model is going to be smart enough to send him off somewhere. We do that by Unity is going to call our backend through REST. There we have LangChain for J in our Quarkus service. And then it's going to, through the LangChain for J APIs, we'll be calling Olama to get the response we need. I'm using Llama 3.1 with 8 billion parameters. I know there is a 3.2 version which is more lightweight with like 1 billion parameters, I believe. I tried running that. All my demos broke. So, so I did the next best thing. I just reverted back. Yeah, so if you look at the orcs here, we have Ugluk here. And you can see he walked over to Musgash. I didn't come up with the names, by the way. It's, an LLM did that for me. And you can see that he went there and he's like, what's the strategy for taking down our enemy stronghold that you've been thinking about? I'd love to hear your ideas. That's an opener for a conversation, I guess. And then he answers with, actually, I was thinking more about how we can use our knowledge of the surrounding area to our advantage. Okay, maybe this is not really a conversation to be hearing as Frodo. So how does this work? we have a command endpoint, and our front end's calling the command endpoint. We get a villager for a repository, and basically all the villagers, I could have put them in a relational database, but I just have them in code here. It's pretty much the same in this case. And they all have a name, a job, an age, a personality, and a small description. Interestingly, these are the personalities. I also tried making some orcs cruel and malicious. The large language model really did not like that. It was like, how dare you ask me to be cruel? So yeah, I had to comment those out. I did hear. I was in Devox Morocco last week, and somebody told me that I should try reverse psychology on the large language model to see if I can get it to become cruel. I was like, that sounds kind of cruel. All right, so we get the villager, and then we sent a prompt to the large language model. As you can see, all the prompts are quite sizable. And we're telling it, OK, you're commanding villagers in this village. It's a tranquil little village, whatever. These are the 3 actions you're allowed to do. Move to someone, move to somewhere, talk to somewhere, or do nothing. So it's not like they can decide to do a backflip or something like that. Some action constraints, interaction limits, things like that. And some examples on how the format will look like. So the most tricky part of this whole system is actually getting these prompts right. But of course, you want to get your response in a structured manner, like hopefully like an object. Here you can see I'm returning a string. I'm getting a string back from the large language model. That is because I found out, and with the help of some tweets from Guillermo Laforge, I'm not very good in French. I think he's also giving a talk on RAG, I think today, from Google, and he said, if you ask a large language model to be creative, but also give it a lot of restrictions, it's going to do one of the two and not really be able to do both. And I really saw that because I'm asking it here to be creative, tell it, OK, where is this org going to be going and what it's going to do, but also give it a lot of restrictions and then asking it, OK, give your response in a very structured JSON. And it was not able to do that at all. So it either was giving me only the same thing, same response back all the time, or just giving me rubbish JSON. So what I end up doing is have a second agent which gets the command from the first agent, judges it, and then is like, OK, this is good enough. I'm going to structure it into a JSON, and then I'm going to send that into the JSON. So this is the prompt. What's really funny, so this is the JSON basically that we'll be receiving. In the prompt, I say your output must strictly, and I mean it, adhere to the following JSON format. And you're like, OK, this does nothing, but trust me, it does. Because before I put I mean it there, I was getting sometimes a JSON back that was missing like a comma or something like that. And like this, it was always good. So you have to be strict with these models. They're like little children, I think. Oh, and here we can see that little speed hack. There we go. He's moving somewhere and to the Garden of Serenity and going to talk there. And as you can see, like this, they are moving around. And then, of course, when we get a command, we change their state, make sure the whole system knows what the state is of an org and things like that, to be able to give good responses next time. And then we use LangChain4j's memory, which is built in to be able to, and the orgs remember from each other what they have said to each other. So every org conversation has its own memory, which is pretty cool. Yeah, so that is a little bit how we move orgs around. But of course, the next thing that you want to do is, as Frodo, if you're at a little village like this, is move around, talk, and actually talk with orcs, I think. So Frodo is going to be like strolling around, going on an orc, asking any kind of question, and the orcs are supposed to answer, hopefully. of course, we have some imaginary history for the imaginary land of Mordor. Imaginary and imaginary, kind of weird, I guess. So I have here a little history of the whole village, when it was created, why, and things like that. So this is a lot of text. And what we do with this is we use a text splitter that LangChain4j also gives you, and we split it in little chunks, and then we put it in a vector database. So to be able to do this, basically we have a Docker container running VV8 that we put all our text chunks in. And then whenever Frodo asks something to an orc, we'll grab that question and we'll send it to the vector database and hopefully get a relevant response. Now, this all can be abstracted away by LangChain for you. So you'll just say, okay, vector store.save and things like that. What's a little bit unfortunate about LangChain4j, or I mean, not necessarily LangChain4j, but in general about using abstraction libraries or API libraries like that, is that once you want to go off the beaten path, they don't support that, right? And VV8 has very good models themselves, so they provide you Dockerized models that you can run locally. And whenever you send any form of text to the database, they will auto embed the text for you and put it in the database. So you don't have to do that yourself, which is quite nice. You just send, as you're used to with a relational database, you just send your text there, and they make sure it's vectorized, put in the correct schema and things like that. And that isn't supported by default by LangChain4j. So what we do is we actually use the VV8 Java client ourselves directly to do that, so that I don't have to vectorize all these things by myself. Now, so this is an orc, Frog, and then we can ask him, who are you? Or who are you, for example. He's Frog, trader, and entrepreneur. I've made a name for myself in LMM, and my business dealings have earned me both respect and distrust among the villagers. I mean, he's very honest. And then, of course, what is this place? A village in Mordor where he's made a home, tranquil oasis nested among the shadows of darkness and conflict, ominous. Yet we strive for peace and prosperity here. Does anybody have a question for Frog? How old are you? Let's see if they know. He's a young 39 winters old. Still in his prime. You can see it on his mustache, I guess. Old enough to know the ways of this village, but young enough to have opportunities yet to come. So sounds kind of ominous. Do you know Frodo? The halfling and his companion, yes. Oh, Frodo bangings. He knows a lot. But they avoided Little Minas Morgul itself. We're not exactly welcoming to outsiders in these troubled times. Okay, nobody say anything. So we'll leave him be. And we'll go to Mahur. And be like, I don't know, do you like waffles? You think I'd concern myself with such trivialities where there is so much darkness? Okay, sorry. But he's a shaman and he has more pressing matters to attend to. The well-being, yeah, okay. So you can see they do actually adapt a personality and try to answer based on that personality and things like that. So that's quite nice. So whenever we chat with a villager, we get the villager, of course, from our repository. We get we get the context from VV8 of the query, and then we do some chatting. What's good to know is that we ask the Olama not to give responses back more than 300 characters, because if you let these large language models talk freely, they really talk. They really like to just go on and on and on. And we'll see more about that later. And Anybody that wants to know anything about this or wants to try to break my demo, maybe? It's also allowed. Yeah? The, there is a cook somewhere, but let's ask the shaman. Can you give me a recipe of some cookies? I think that's a no. Those wheat treats here, meat is not back on the menu yet. If I had a recipe for cookies, it would be one for resilience and hope, not some frivolous pastry. Oh my God. Okay, let's see if we can find a more jolly person. Gorbagol. So let's see. Do you have a recipe for cookies? Oh, but only if you catch the cookie fish in the streams nearby. Oh, he's a fisher. Gather some honey from the bees in the meadows, mix it with crushed nuts and dried fruits, and bake them on a stone fire until they're golden brown. That's my orcish cookie recipe for you. Is that good enough? Okay, now I'm curious what he is. Gorbagel. What was his name? Gorbagel. He is a fisherman indeed. Oh, no, wait. He's Gorbagel's... Oh. He's indeed a fisherman. Okay, so we got that right. All right, so like this, you can actually add quite simple rag flows with text in your systems. You can see that if you ask in a large language model to, be cool, this is your personality, give it some restrictions, and have a second agent next to it that is kind of controlling the answers of the first agent, you can create quite nice rag flows, I believe. All right, so this is the bridge to Mount Doom. Okay, this is where I need to be. So let's continue into using image rag. If you look at the orc there, it's an orc. Does anybody maybe recognize him? I heard it here. So it is supposed to be Bob Ross. Or as I like to call him, wait, I'll just walk up to him. There he is there. Bobu Rogosh. And he says, a very happy little accident that we are there. Okay, so as you saw, we walked around, got to Bobu Rogosh, and we're going to be asking Bobu about his paintings, what he do, maybe make a painting our own and see what happens. We do that basically by just also adding lava next to our llama model. Now, this is going to be a little bit slow. Ollama supports multi-model, running multiple models. And it wasn't working on my machine, and I really didn't know why. And I was cursing Ollama, then I was starting cursing Launch-A4j. I was like, nothing works, what is this? I went on Twitter asking people for help, and then, of course, found out that the problem was between the machine and the chair, so to say. So it was me. And my laptop couldn't fit both models on the GPU at the same time because I'm an 8 GB GPU. So what's going to happen now, whenever we do these calls with images, Ollama is going to stop the text model, start the vision model, Lava, do the transcription, do whatever it needs to do, then stop that model, and then start again the text model. So that will take a little bit of time. And whenever we draw images or use images, we're going to be using a clip model to embed these images. A clip model is a so-called multimodal model, which allows you to put images and text in the same vector space. So that allows you to search for images with text and vice versa. So that's pretty nice. Okay, so of course, who are you? Because Frodo has no idea, right? He's Bob Rogos, an orc painter. He adjusts his hat that he doesn't have, but you know. He's a renowned artist, and I'm thrilled to share my passion for. My paintings capture the beauty, challenging. So he doesn't have a max amount of characters. And as you might have noticed, I have a canvas next to me, and he's like, draw something. Okay, cool. I guess I'll go there. All right. I'm not the best drawer, but I'll try. What should I try to draw? Anybody got any wishes? A hat? That's easy enough, huh? Sorry, I heard in Gundam, but Gandalf. Okay, so let's go like this, this, and then we have a little pointy hat, and then something like, oh my god, this, and then, all right. You know, there's beauty in simplicity. And of course, he has like, uh-huh. And then, oh my, there we go. Thank you. And then we submit it. So now it's the part that's going to take some time. So you can see here transcribing an image as an orc. And then we're going to transcribe the image. The lava model is going to be like, okay, this is a beautiful image, expertly crafted. It's like I'm looking at Picasso myself. And then generate and send that transcription to Bob Rost, and he's going to create a little text around it. So he's going to put the orcish spin as delightful adoring. Morgul's witch's tiara. What? The pointed ears on top give you a regal touch, don't you think? And the brim at the bottom is adorned with intricate etchings that resemble the swirling patterns of the ancient Mordor script. The beard is black speech. What? The face. Yeah. Okay. So you can see he really tips his painter's hat. But yes, this is indeed a masterpiece. I couldn't agree more. As you can see, like that, you can just draw something and have all the large language models transcribe it and generate something cool out of it and get something cool. But of course, I mean, drawing things is interesting and kind of cool. But that is not all we can do, of course. Wait, a little bit of speed hack. I mean, I wouldn't be a game developer if I didn't add any hacks. There we go. So now we are the shopkeeper. And he's like, hey, want to buy some paintings? And we can ask him, again, who are you? And then he's going to give us a little response. He's the shopkeeper, the friendly and enthusiastic in Little Minas Morgul, around this lovely blah, 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 blah. And he sells the paintings made by Bobu Rogos. He loves sharing these things, etc., etc. So you can see, you can also chat. You can chat with him and do things like that. But you can, I want to buy a painting. So now you're like, yeah, I want to buy something from you. It's a joke, of course, Frodo doesn't have any money. But we'll just browse around. And what's really cool and what you can do with large language models is you can ask them to identify what kind of questions you are receiving. So here we can, when we're talking with a shopkeeper, chat with shopkeeper, we are asking our judge model, what kind of question are we receiving? And if we're receiving just a chat question, or if we're just chatting, we just send the messages to the large language model. If it's a history question, there is a to-do here. Classic. And if we're shopping, we basically say, okay, this is the message you receive. Let the customer know that you only have paintings if he's asking for anything else about a painting. And if he's shopping for a painting, we basically send to the large language model, hey, he wants some paintings, you hooked somebody, say this, and the final word of your response should always be ka-ching. because we're spending money, of course. And what we do in the front end, when we see the word kaching in the response, we open up a UI where you can buy paintings. And this is it. So like this, you can actually create different flows and different actually different UI interactions by just telling the model what kind of response you want or give it restrictions on what kind of responses it should give. So that means that, I mean, now I just use a simple word, but it can be completely different form of JSON, right? And things like that. So let's start do you have a painting of a nice house in the snow with mountains or something? And as you can see, I mean, I would say this is a painting of a nice house in the snow with mountains on the back. So what's happening here, I have all the, here, I have a lot of paintings from Bob Roche. I got them from Kaggle, and Kaggle's a website where you can download all kinds of free data sets. So I have all these paintings from Bob Roche. I put them in the vector database using clip, and then you can actually query for those paintings using just text. And then, of course, the shopkeeper is going to receive this painting and is going to be like, he wipes the sweat, okay. Great eye for art. Let me tell you, my friend, the painting is not just any ordinary winter scene. No, no, no. It's a capturing essence of peace and tranquility. Okay, okay, okay. And as you can see, he also doesn't have a 300 character limit. Now let's talk about pricing. And we get a discount for some reason. So as you can see, like this, you can search for images or things like that. Anybody that wants to search for any sort of image? For example, we could do Mount Doom or painting of Mount Doom. Let's see what we get. I don't know, did Bob Ross make a painting of Mount Doom at some point in his career? I don't have it, probably though. But yeah, I mean, we still, I guess we at least found a mountain. That's something. Omar, you've got another masterpiece in front of you. Okay. So now it's generating the response. And while it's generating the response, my laptop is complaining. But what we can also do, of course, is paint something, or scribble, better said, I guess, and try to find images based on the scribble. So if I, for example, do something like this, super happy, and submit this. Okay, so what's going to happen now is we're going to grab, we find something quite similar, I would say, right? So yeah, what's happening is we're grabbing this image, we're vectorizing it, and we're searching for anything that is similar to this. And I'm really curious if he's going to call this a masterpiece as well. A rare find in front of you. The simplest yet most elegant line drawing by Bobu Rogosh. A true masterpiece, again. I mean, I don't want to boast, but and what we could also do is, do you have a painting of a wizard with a hat? So this is done. And there is the painting we just drew, which now I understand that's a wizard with a hat. So I don't know what Bobu Rogosh was talking about. So basically, we drew the painting. As we drew it, we immediately vectorized it, put it in the vector database. And I'm pretty sure in the future I'll be giving a presentation. Completely have forgot that I drew a wizard with a hat somewhere. Be like, yeah, I'll search for this and won't be able to find it. And then it's going to be in front of me and be like, oh no. And another masterful painting, of course. Yeah, so yeah, the orcs are chilling here nicely. So let's move on. the last thing I want to show you is audio rag. A little disclaimer, I'm a metalhead myself. I listen to a lot of metal music. Some people call it degenerate metal music, but you know. Any other metal heads here? Amazing. Anybody else that really doesn't like heavy metal music? I knew Stefan would raise his hand. I saw a hand back there. Is that also the person that didn't like Lord of the Rings? No? Okay, just making sure I didn't get like a double. Okay, so we're going to be walking around. We're going to find an org that really likes playing music, and we're going to be querying things and see if we can find music. To make this happen, so basically we have everything as is, but unfortunately, we had to add a little bit of Python in between because we're using a clap model, Microsoft Clap, which is very similar to Clip, and where Clip is for images, Clap is for audio. So the E in Clip is image, and the A in Clap is for audio. Great naming, actually, now that I think about it. But the Clap model, I couldn't find a Docker, I couldn't Dockerize it, I couldn't find a nice wrapper I could use for it. The only thing I could really do is wrap it around, load it into in a Python server. So this is the Python server, and load it around a REST API to be able to call it. So what we're going to be doing here is we're going to create audio embeddings of some audio files I loaded in, and also trying to transcribe the audio that it listens. So like this, we'll be able to search our audio with text and text text with audio. We are not done yet. Spoiler alert, we are almost done. So we are walking around. This is a forest with no spiders, also important to know, I guess. And this is the metalhead. Maybe something gave it away. A new face, want to hear some awesome metal? Yes. Let's start with a good old who are you? See what we get back as a response. Dude! I really don't know. I told the large language model, you're a metalhead. And then it went full like stoner mode. Like, dude, the greatest problem is this side of Middle Earth. Bounce fist on the table, okay. I'm an orc, but don't let that fool you. I've always got a heart of gold and soul, and that's dedicated, spraying the... Yes. I mean, I could hang out with this guy, I'll be honest. Let's rock this place, okay. And then, of course, we can do the same trick. Can you play me some metal? And now, again, the large language model is going to get this answer. It's going to be like, okay, he's asking to hear some music. I am the metalhead, so I will be generating some, I will be opening the UI for the music. Hopefully. Yes. So he's like, you want to hear some tunes, etc., etc. And then we can say, okay, let's double check that my sound is on. A violin tune. Oh, this is not going to work, of course. Let me close. Did I break everything now? Because I forgot to start the Python server. Important, if you are trying to call certain servers, make sure they are running. So can I type? Okay, a violin tune. See what happens now. There we go. He's playing sad violin A for you. Here are the lyrics. And he's going to generate some lyrics for you as you go. So we are asking, hey, play us a violin tune. Then we transcribe the text or vectorize the text, search it in the vector database, find a violin tune, send it back, and then also inject the transcription of the audio in the prompt to generate lyrics. So it's like, but then I pick up my axe and let the riffs unfold, a sympathy of feel. Okay, doesn't sound, so we can go, how about a heavy metal song that is very loud. See if we get what I hope I'm gonna get. Guitars well solo. So this is not what I wanted. I mean, this is kind of heavy metal, right? I mean, distortion, guitar. And that is a little bit the problem I'm having so far with these audio models. It's really tricky to find what you're searching for because they kind of default to sounds. Okay, this is music, this is loud music. But if you're like, hey, I want a power metal song sung by this and this and this, it has really no idea. Okay. What if I go, how about a power metal song that is sang by orcs, very loud, aggressive. Oh, that's a good one. And I mean it. The fury, pulsing rhythm. I guess this is the aggressive part. Not bad. Okay, so I'm gonna leave the aggressive and then try one more time. No, we get the same. So the aggressive wasn't a problem. Of course, something else you can do. Oh, he's generating the lyrics first. What you can also do, of course, is draw something and hopefully get a song representing that. So I'm going to try to draw it quickly because I have only 3 minutes left. So this is supposed to be, well, a violin, but sure. Guitar, violin, basically the same, huh? So I'll draw this on the side. So maybe it understands now that it's supposed to be a violin. I'm going to submit this. And this is going to take a little bit of time. So it's going to grab this, transcribe it, send it to the Lava, to the vision model. The vision model is going to be doing its magic. Then create a transcription. The transcription is going to go to the Python server. And then you get your guitar. Yeah. It was a violin, though. All right. So with that, because I have 2 minutes left, we found Sam again. And I think it's time to leave this little peaceful village of Little Minas Morgul. But the people that saw Lord of the Rings know how the movie ended, with Frodo Gollum jumping into the lava, which is of course very sad because whole of Mordor got destroyed. And this is a village in Mordor, meaning that shortly after Frodo left, the whole village kind of, got obliterated in the aftermath of the War of the Ring. And all these nice orcs living the life, perished. No other way to put it. And that is a little bit all I had to show you today. It was really fun playing with large language models and trying to fit them to create this vision I tried to recreate. So hopefully you found it enjoyable and maybe inspiring. I can't wait to see what some of you, or maybe all of you, do next with this, and maybe next year some of you will show it here on stage. So yeah, thank you very much. So we don't have time for questions, but you can just come.